Welcome to Mr. Angel Lizzle's super awesome math class. Today's lesson is on topic 26, graphical displays of association. We looked at association of two categorical variables in the last unit when we discussed chi-squared. Now we're going to be discussing the relationship between two quantitative variables. So when we're examining a relationship, or any data set that we're looking at, we're going to look at these three things first, like every problem we've done this year. Determine what individuals the data describes. What exactly are the variables? How are they measured? And are the variables categorical or quantitative? We should have this down by this point. It's the first thing we do whenever we're looking at any data set. The next thing, if we have bivariate data, we're going to want to look to see if we can identify an explanatory and a response variable. Remember, our response variables measure an outcome of a study, also called a dependent variable. Response variables can go on the y-axis. Explanatory variables attempt to explain the observed outcomes, also called the independent variable. We're going to look for cause and effect relationships, even though there may not always be one. So examples, alcohol and body temperature. Scientists did that study on lab rats and injected them with alcohol and measured the change in their body temperature. So the explanatory variables, obviously the amount of alcohol they're getting, and then the response variable is the body temperature of those silly drunk rats. Next one, SAT verbal and SAT math scores. Do we think there's a strong relationship between those two? The people that do well on the SAT verbal do well on the SAT math? Yes, and vice versa. Does one necessarily cause the other? No. So there's probably a strong relationship here, though there's not necessarily an explanatory response variable. So keep that in mind. When we don't have an explanatory or response variable, we can choose whichever one we'd like to go on the X and the Y axis. So we're always going to plot the data and add numerical summaries. The plot for bivariate quantitative data is actually a scatter plot. We're going to look how to construct those today. So we're going to look for overall patterns and deviations from those patterns. But the main purpose of the entire lesson today is to identify three things when we're looking at scatter plots. First, form. Our data can take many forms. But for the purposes of an introductory statistics class, we're going to look at just two. Is it linear or nonlinear? I guess we could throw a third in and say that there's no relationship, right? But in the next statistics class you'll take, we'll be fitting curves and all sorts of mathematical models to fit your data sets, not necessarily just lines. Two, direction. Once we see if we do have a linear relationship, we're going to want to go ahead and decide whether or not the slope of that line that seems to be the best fit would be positive or negative. We're going to choose positive or negative. And the third thing we want to identify when looking at scatter plot is strength. How strong is the relationship? So we're going to say strong, moderate, or weak. So three choices. Before we look at these, we're going to put judgment on. This first unit, we're not going to add any numerical summaries to describe the strength of the relationship, but in the next unit, topic 27, we will. Now, scatterplots. Just listen to this. You don't necessarily need to jot this all down, and I'll post the notes online if you'd like to print them out. So the best way to describe a relationship between two quantitative variables is a scatterplot. Scatterplot shows the relationship between quantitative variables measured on the same individual. So each dot in our scatterplot represents one observational unit in which two things are measured. The values of one variable appear on the horizontal axis, and the values of the other appear on the vertical. Each individual in the data appears as the point in the plot fixed by the values of both variables for that individual. There is no distinction between explanatory and response variables. You may plot either on the horizontal axis. All right, so here's an example of scatterplot. Remember, we're always going to title. We have weight versus fuel efficiency for cars, right? And this is fuel efficiency by the number of gallons it takes to drive 100 miles. So the heavier the car, the more gallons it takes to drive 100 miles. So the worse fuel efficiency. So how would we describe the form, direction, and strength? Would we say this is a linear relationship? Yeah. Yes, I would say a line would fit it quite well. Is it a positive or negative linear relationship? Positive. Positive, pretty straightforward. And this will take a little bit of getting used to. Is this strong, moderate, or weak? I'd say moderate. If you said strong, I wouldn't disagree with you there. There's definitely a distinct shape. So I think go in between to moderately strong. So when we're examining scatter plots, look for overall pattern and striking deviations. And as discussed before, describe the overall pattern by the form, describe the direction, describe the strength of the relationship. An influential observation is an individual value that falls outside the overall pattern. So if I'm looking at something like this, if I had a data point down here, that would be an influential observation outside the overall pattern. Right? We can have them above or below. But think of an observation that if we did have a line going through our data, our line of best fit, something like that.
Oh, that's fancy. How'd you do that?
All right, so there's my line of best fit. Having an influential observation out here is going to be something that pulls that line down, so it doesn't really fit the overall pattern. So it's influencing a regression line by tugging it towards. All right, positive or negative. So this is another thing that doesn't necessarily need to be written down. This is common sense. You're all in an AP class, so this should be straightforward. Positive association. Above average values of one variable tend to accompany above average values of the other. Negative association. Above average values of one variable tend to accompany below average values of the other, and vice versa. Tips for drawing scatter plots. We're going to draw a couple scatter plots by hand here, but most of the time we're going to rely on statistical software and our calculators to crank out a scatter plot for us. We're going to examine it. For the purposes of the AP test, oftentimes you'll be given a scatter plot. You may have to add something to a scatter plot or analyze it. But remember, the AP test is a time test, and they don't want you to spend a lot of time doing something as meticulous as drawing a scatter plot. So we're going to scale the horizontal and vertical axes. Intervals must be uniform. If scale does not begin at 0, we're going to indicate a break. So when we don't begin at 0, we can indicate a break a couple of different ways. So a break can be indicated at just those two lines there. It means we're not starting at 0. Or the other way to do it is that zigzag line like that. That means we're not starting at 0. Let's get it up there. Label both axes. Make the plot as large as possible, and be sure to title. Title your graph appropriately. All right, so some examples of positive linear association. We have a positive relationship, strong positive, and then perfect positive. We don't necessarily see perfect positive when we're dealing with real life data. Negative, obviously. Strong negative, and then perfect negative, right? If we fit a line through there, the slope would be negative. And then no correlation. You can't really see which direction we fit a line, whether it would slope up or down. And then this has a very strong relationship. However, is it a straight line? No, so it's a nonlinear relationship. All right. So thank you for watching my sweet video. I will see you next time in topic 27. Signing out.
Like and subscribe.